Hey everybody, Mr. Piercy here, and what we're going to do is, in this demonstration video, is identify the properties of an inscribed angle of a semicircle. So for this demonstration, if you're going to try and follow along and recreate it on your own, we'll need some paper, pencil, a compass, and our protractor, so that way we can not only have a straight edge, but measure some angles. So to start off with, we'll begin by creating a circle of some decent size. We don't want it to be really, really small. We just want it, but we don't want to necessarily make it fill up the whole paper either. We need something that will be large enough that when I draw the angles on the circle, we will be able to measure them with the protractor. Now that I have a circle drawn, what I'm going to do is just kind of anywhere on there, we're going to draw in the diameter of the circle, and it doesn't really matter where you do it. If you want to do it horizontally and so it looks more like that, you're certainly welcome to. It's just, as long as you have a diameter on your circle somewhere. So we will call the diameter A, B, and I'll call the circle circle X. Now what I'm going to do is I'm going to kind of just pick a spot on the circle. So by adding the diameter, I've created two semicircles. I have a semicircle here kind of on the right, and I have a semicircle here kind of on the left. So I'll call this point L, just to give myself something. Uh-oh, announcement time. They seem to be doing some kind of testing with the uh, overhead announce system here, so sorry about that. But we're going to go ahead and draw in the inscribed angle of the semicircle. So we have these points here, and just to illustrate the point, of what we're looking at here, I'm going to give myself a couple more. Let's do one here in red, and we'll do one here in blue. The red one, we'll call this one M, and the blue one we will call N. Now, again, I'm going to just draw in the inscribed angle of the semicircle. And as soon as I have them, we will go ahead and start measuring them. So one more. So now we have three inscribed angles, and we want to know what are the measurements of the inscribed angles. So we have three that we're going to be looking for. I want to know what is the measurement of angle ALB. I want to know what is the measurement of angle AMB. And I want to know what is the measurement of angle ANB. So let's go ahead and measure our angles here. Let's start with the first one, ALB. And let's see, lining the protractor up with the angle here, you can see, let's go ahead and zoom in a little bit. The measurement of the angle is 90 degrees. Well, what about the other two? So let's turn this one around here so we can see it, measure it this way. And lining that angle up, we can see that the red angle here is also 90 degrees. And finally, measuring the blue angle, angle N, if I were to measure this angle, we see also that it has a measurement of 90 degrees. Now, this property isn't really all that surprising, since the measurement of an inscribed angle is going to be half of its intercepted arc. Well, if I wanted to know the measurement of arc ALB, because the endpoints of the arc are the diameter of the circle, the measurement of arc ALB would have to be 180 degrees. So its inscribed angle would have to be half of that, which is 90. But the conclusion that we're able to draw here is that angles inscribed in a semicircle will be right angles. And that is the overall conclusion that we're looking at here. That if I have an angle that is inscribed inside of a semicircle, then the measurements of the angles will be 90 degrees, making them right angles. That's it for this demonstration. If you have any